Okay, lesson 3.4 of Honors Algebra 2. Three variable systems. These problems have no more math skills than we had in 3.2. The problems are just a lot bigger. Instead of looking for two variables, we're going to be looking for three. You're still using substitution, you're still using linear combination. You need to look at the problem and decide what method's going to be best for this situation. Staying organized is extremely important. It's a lot of work. There's going to be stuff all over your paper. You need to stay organized. So whatever is the best way to organize for you, that's what you're going to have to figure out. Make sure that you watch your basic computations. Adding, subtracting is usually where I find most of the mistakes. There's a lot of work to go through, so you really have to take your time and do those calculations, double check your work to make sure you did that correctly. We're going to do substitution first, or at least look at a problem that I would use substitution for. This is where problem solving, puzzle pieces. If you're a problem solver, usually it's going to be a little easier for you to see where to start from. Okay? 2y equals 10, 3x plus 5y equals 34, 5x minus 2y plus 3z equals -1. For this one, I'm looking at the smallest equation. I can see I can get one variable by itself. It's not always going to happen that way, but when it does, take it. 2y equals 10. You can solve for y right now. We need to solve for three variables, x, y, and z. So if you can get one of those variables right away, y equals 5, take it. Okay? Now once you have that 5, look at where you can put it. Okay? You're trying to get an equation that only has one variable to it. Okay? So if I'm looking at this second equation, 3x plus 5y equals 34, I can take that 5y and plug it in and get an equation that just has x in it. Okay? And these should be equations you should be able to solve. 3x plus 5 times 5 equals 34. Multiplication, subtract, and divide. These are multiple step equations, but they're linear equations that you should be able to get that variable by itself. 5 times 5 is 25, subtract, 3x equals 9, x equals 3. So now we have x, now we have y. Our last equation here, 5x minus 2y plus 3z equals -1. Yes, it's big, it's ugly, it has three variables in it, but we know two of the variables. We can plug in and then solve for that last variable, z. Okay. And just doing some multiplying, combining like terms, we get 15, 10, 15 minus 10 is 5 plus 3z equals -1. Subtract your 5. Z equals -2, x equals 3, y equals 5. Okay, I still would like you to write this as a point. It's not an ordered pair because it's not two terms, but it's a three-dimensional point. That would be in a three-dimensional. We're not going to be graphing them at all, but I still like you to write it alphabetical order, x, y, z. And there would be your final answer then. Okay? So this one was nice. It worked like a ladder. Top equation, you saw one variable, so I got that one variable by itself. And that's what you need to look for. Where's the starting point? Okay? It's not always going to be one equation that already has one variable to it. You're going to have to look in, like I said, puzzle pieces. How can I put these together to get where I want to go? I want to get equations that only have one variable in them. This next one, 4x plus 4y minus 2z equals 16, z equals -2x plus 2y, y equals 3x minus 9. There's not an equation that has one variable in it. I can't solve for anything and get one value that I'm looking for. Okay? Y equals 3x minus 9. That's the smallest one that only has two variables in it. Okay? But I can't solve to get that variable by itself. Z equals -2x plus 2y. Again, that's three variables to it. On top, I have another three variable one. Okay? Now, what I like about this middle one, though, is that it has z by itself already. Okay? So what I want to do, I'm going to take this y, and this is guessing and checking almost, working through the problem and seeing if you can get a variable by itself. I'm going to take this y here, and plug it into that middle equation. Okay? So I'm going to take z equals -2x plus 2, plugging this in, 3x minus 9, and I'm going to simplify it to z and see what I have then. okay? Because now I only have two variables here. Now I have z and x. Z equals, doing the distributive property gives you 6x minus 18. I'm going to have 4x minus 18. So I have z, I have 4x minus 18. Y, I have 3x minus 9. Okay? A z that equals an x, a y that equals an x expression. So now I'm saying, what can I do with those two? I'm going to go up here. 4x plus 4y minus 2z. I can get rid of my z by plugging in. I can get rid of my y by plugging in. I'm going to have all x's in that equation. So let me write that out and see what it looks like. 4x plus 4, just make sure we're plugging in the right expression. 3 minus 9 minus 2, this is 4x minus 18, everything equaling 16. Okay? This is what I mean by some of these things get pretty big, you have to be organized. Okay? It is a big equation, but once you start simplifying distributive property, combining like terms, it's going to shrink down to something that we are a little more familiar with, or that looks a little simpler by the eye. Doing the distributive property, we get 12x minus 36, negative 8x plus 36 equals 16. And looking at it, look what happens. Negative 36, 36, they cancel out. 4x plus 12x is 16, minus 8 is 8x, equals 16. Like I said, it's simplified to a nice small equation. 8x equals 16. Divide by 8. And now we have x equals 2. Okay, so now we have 1/3 of our answer, x, y, z. We have our x equals 2. But also look what we have. We have x. We have z that equals an x expression, y that equals an x expression. So you can just take that x. I'm going to plug into these two expressions and solve for the variable then. Simplify it. Z equals 4 times 2 minus 18. That should give us z equals negative 10. 4 times 2 is 8 minus 18. Yep, we get negative 10. 3 times 2 minus 9 gives us y. And that should be y equals negative 3. So there's our z, there's our y, there's our x. 2, negative 3, negative 10. Okay? And again, it's important. Take your time, go through your work, make sure you're adding, subtracting correctly, make sure that you are watching your signs, especially when you start dealing with negatives. Up here, the common mistake I see is negative 2 times 4x is negative 8x, negative 2 times negative 18. They would write it as minus 36. Take your time, two negatives make a positive when you're multiplying. Okay? So there's two examples of using substitution. In the next video, I'll show some examples of linear combination. Gets a little trickier, I feel like. This is the easier of the two methods. So this is a good place to start and seeing these two examples.